Previously we were looking at the fundamentals of Pandas, which is one of the very important tool in order to do the data processing. So it takes the data in generally two formats. One is called as a series, and the second one is called as the Pandas data frame. So we were exploring various concepts related to the Pandas data frame as well as Pandas series, in which the most recent topic we were discussing is called as the joins. Okay, so I'll quickly give a recap of the joins concept which we were discussing, and then we'll directly proceed further. All right. So if you can see here, so line number 2 is basically we are creating a particular data frame, and this data frame basically consists of employee names as well as the various divisions to which these employees belong to. All right, so that's what we can see here, and the output, right? This part of the code already I have included in the previous session, so I simply have copied and pasted so that we save some time. All right. Data frame 1 is that. Data frame 2 actually talks about what are the various employees and their date of join. Okay, and in line number 4, you can see we are trying to merge the data frame 1 and the data frame 2. We call that as data frame 3, and if you inspect the data frame 3, this is how it looks like. This is called as a one-to-one merging, where you see what is common between data frame 1 and the data frame 2. So data frame 1 basically has employee names as a series, first column, accounts as the second column. Similarly, data frame 2 has employee and the date of join. Correct. Now, this data frame 3 we obtained by merging, and this merging is called as one-to-one. During this merge, the names, employee names, have been considered as the main element, right? Irrespective of whichever is the division it is, it adds the date of joining and it clubs that. You can see the order in which we have entered is completely different. You can see here, look at this output. So it is in order Bharat, Chandra, Dhaarini, Srivalli. At the same time, the data frame 2 is arranged in a different way, right? See, the order is completely different. But what this merge has performed now is that it actually took, right, proper name, right? So that irrespective of whatever division it is, it adds the proper date of join to in front of that particular name. So Bharat belongs to accounts, which is the first element in the data frame 1. At the same time, the Bharat is actually located as a third element in data frame 2. So you can see this is called as one-to-one, right? The properly it identifies which is the name, irrespective of what is there in the second column. Third column is arranged properly, right? That is very important. So this is what is called as the one-to-one, right? Merging. Now we see, we'll go further and we'll look at what is called as many-to-many join. This is also one of the very important type of joins that we might have to use whenever we go for a data processing in our main projects. Okay, so let's create another data frame. So this is something like the division and the funds. So that is what we call as data frame 4. Now you see we are trying to club the data frame 3 and data frame 4. Okay, I think this is also we have covered. This is not many. Okay, this is not many-to-many. This is called as many-to-one, right? So why we call it as many-to-one? Because you see divisions are different, right? The ones which we have already considered, that actually belongs to the employee names. Employee names has an account, but there are different types of divisions which will be assigned to these names. So you see here, the particular R&D, which is 1. Okay, many means, you see, you look at Chandra and Dhaarini, they are belonging to R&D. So many names are actually assigned to one particular division that actually is called as the R&D division. So you can see that whenever I clubbed, right? I think data frame 3 you should see here. So this is the data frame 3, and this is the data frame 4. We are performing many-to-one merge here. So many names will belong to the same division, but each division has a different fund. So table number 2, that is the data frame 4, is called as that one table, and many comes from the data frame 3. Data frame 3 has many names. So few of the names may belong to same division. You will, when you club the data frame 3 and data frame 4, you are performing what is called as many to one merging. All right, very important. Then now we are going to the next topic. So till here we had discussed in the previous session. So what we do, we'll start with the coding. So we'll write what is called as data frame 5. Data frame 5 is a division. Already we know the divisions, and we'll write what are the various skills required for to be present, to be an employee of a particular division. What are the various skills required? You can see that, right? So as we can see here, accounts requires finance, accounts also requires Excel. R&D requires programming, R&D requires Linux, right? HR requires management, HR also requires a training requirement, training skills. Now you see that this is another data frame, okay? Different names have different skills. So this is many, or you can consider this particular table or the data frame actually contains many data. Now we'll also consider another data frame which has many things present over there, like the many names having the same division. Now you see employees versus division. So employees are different, employees belong to different divisions also. So this is also a many type of what you call as a data frame, right? Now we try to club this data frame 5 and data frame 1 over here. pd.merge data frame 1 comma data frame 5. So the many which were present originally, they will still be there. Okay, if you don't have a copies, sufficiently large number of copies present, it will automatically make that happen. You can see here, Bharat was only one in this case, but Bharat belongs to which division? Account division. According to this data frame number 5, accounts requires two different skills, correct? So now you see, Bharat belongs to accounts, he has a skills called finance. Bharat belongs to accounts, he also has a skill called as Excel, right? Same thing happens with others, right? Other candidates also. So this kind of merging is what is called as, right, the many to many. All right, let me know if you have any doubt with this. Otherwise let's proceed further. So there is what is called as a keyword called on. All right, so let me show you another version of this. So let me try to type what is that, my data frame 1. I'll try to print it once. Also I'll try to print the my data frame 2. So we are fine with this. Now the next objective is that I will use what is called as a on keyword, right? So explicitly I want to specify the name of the key column. Which is the key column the pandas has to use, right? So that column name or a list of the column names can be specified, right? I can specifically, explicitly imply that, okay, this is what I want to do. Okay, so just look at this example, pd dot merge. I'll tell my data frame 1 comma my data frame 2. Now I'll specify a keyword called on equal to, I'll say that we have a column called employee. All right, so based on employee you club. This is what I'm saying. Okay, if you don't say, what happens? This was data frame 1 and 5. Okay, let me show you that later. So based on the employee, I want to club data frame 1 and data frame 2. So you can see that data frame 1 is having Bharat, Chandra, Dhaarini, Srivalli, right? So that's what it becomes the key now. With respect to that, I'm merging the other two, right? Like the division plus the date of joining will be clubbed, right? Will be merged according to this. Okay, so that concept is what we call as the merging using on, right? This is also very important. We might use this several times because I want to merge my different data collected by different sources based on some parameter. So in such case, we will be definitely using this. Okay. Now, let us assume that there will be a situation where we want to merge the different data sets having different column names, right? Column names are completely different. In such case, how do you do that? How can you do that? Okay, so for example, uh, one set of data has simply the column name as name, because whatever we have under that particular column heading is names of the employees. But you see here in one of this table, we have saved the name column under the heading employees. See, it's one and same, right? Basically, I should be able to club them. I should be able to merge them. But I should tell, what do you call, I should tell the pandas that they are same so that you can club. Okay, so one table has a name, names saved under the heading names. Another table has a names saved under the heading employees, but they are one and same. So I should be able to club that. So in order to do that, we can use two different keywords. One is called as a left on, one is called, other one is called as a right on. So we are going to look at that example now. Okay, so let me directly create a data frame. So you can see that this is a data frame. All right. Now I'll also show you the my data frame one, so that you can see that the first column is under the heading employee. Data frame 6 has the first column under the name itself. But I should be able to club them because same employees are there under the same heading in a different data frame. So I should be able to do something like this. So this is what is my command. Okay. The command is pd dot merge. I'll specify my data frame 1 and my data frame 6. Both have names saved under different column names. So what I'm supposed to say, I will just mention left on. Okay, I will say that. So on left on, in the sense, this is my table, what comes on the left side. Right on means whatever is there, whatever is that I want to merge, that is what is the right on. Okay, so left on, I'll just say take it as an employee. Okay, employee, right? Then you will also specify the right on equal to, that is name. So I'm simply suggesting that, right? Name and the employees are same for these two table. Left on in the sense my data frame 1. In my data frame 1, name, employee holds the names. So consider that. Right means my data frame 6, which is present. You can see the statement. Statement says that first whatever you have is the left. Second, whichever data frame you are specifying is the right. So left is employee, right is the name. So I want you to club them. Okay, I want you to merge them. So just see this. All right, so easily we could do this, right? So left side and right side, so they are clubbed together, but the name comes in this particular fashion. Okay, now I can actually see, I can merging happened, but I unnecessarily I'm getting a name column over there. All right, so how can you drop that, right? So dropping is possible, right? So can I drop that unwanted column? So the answer is yes. Let me type that. So this is pd dot merge. It's the same thing. I have to type the same statement like earlier. That is my data frame 1, comma my data frame 6. Then I have to say, because I cannot skip this part, I have to do this merge. Then I am supposed to remove that, right? Remove a particular column. So this is my procedure now. So let's see how to do that. So left on, so specify left on is equal to the employee. Employee, all right, and specify the right on, that is equal to, I think, name. So this actually creates the one which we already have seen now. From this, I want to drop something. I want to drop a particular column. How do you drop? So it's very simple. If you remember, dropping is by using dot drop. So drop. What do you want to drop? Specify its name. The column which I want to drop is name itself. All right. And I have to say, right, you want to eliminate something column wise or row wise. Now I want to remove the complete column, right? So what is the axis handle for that? Axis equal to, you can simply say 1, or you can even type the column over there. So instead of typing 1 over there, if you type column, that is also going to work. Okay, let's see what happens. All right, so we can see that employee, the both tables have been clubbed together based on the names. Though the column names are different, we could do that. All right, then let us say there is another approach for this, wherein my problem is I want to merge two different tables, not based on the column name, but based on the index, right? Based on the indices, how do you club that? So in order to perform that, we have to use what is called as a left index and the right index. If you are dealing with the index, this is the method. If you are dealing with the name, it is left on, right on. Okay, so look at the difference. Both approaches are very useful. So let's see. Let me try to create a data frame once again now. All right, so this is my data frame 7, right? So you can see the index is employee now because I use the set index employee, right? Definitely that is possible. If you remember the creation of the data frame, we had an option called set index. Whichever column you want to convert as index, you can do that because indices could be text, indices could be numbers, indices could be a list, etc. Many things we have seen earlier. So same thing has been done here. And right, I will use another one. So you see here, I use the data frame 2, which was already existing data frame. In that, I'm converting the employee particular column as the index again. All right, so now you see the merge will happen in a very similar fashion like the how we use the left on and the right on. So the command will be pd dot merge. Okay, we have created 7 and 8. So my data frame, so say 7 comma my data frame, say 8, and now you use left but index. Okay, so this is left index. You just have to say true. In a sense, yes, use the left index in the sense from the left from the left data frame, that is data frame 7, because in my command I am entering 2 different data frame. Whatever comes first is the left one, whatever comes later is the right one. So left means my data frame 7. In that case, you want to use, so it is true. All right, so if I say right, I have right index equal to, again you specify that as true. Just see, it will be clubbed according to this. Okay, now there is another option which can actually implement left index right on or right index left on. I'll show you this. This is a hybrid mode. Okay, so you can mix the indices plus the columns. Right, if you want indices, you have to use left index, right index. If you want to use the column names, it has to be left on, right on. But can I club them together? Can I do a hybrid type of mixing over here, merging over here? So the answer is yes. Let me show you that. Okay, so let me try to bring in the 2 of the data frame which already have been created. So my data frame, I will try to first print the 7th one, my data frame 7. That's for our reference. And I'll also print my data frame say 3. Okay, so you can see that the first data frame has employee itself as the key. Okay, indices. whereas the second data frame, that is my data frame 3, has employee as a column, index, right? Indices are different, right? So 0, 1, 2, 3 are the indices. So employee as a employee becomes a column here, division is a column, DOJ is also a column. Now, how do I club these two? So this is the method. Okay, so let me try to club them. Okay, I think I got a 3 here. Let me bring the 6 here. Sorry. Yeah. Okay, so you can see that they have to be different. I want to show that even if they are different, I want to merge. So you see, data frame 7 has employee as the key, whereas the second data frame, that is data frame 6, has name as the as a column. Now I want to club for the first data frame. I want to use the keys. For the second one, it is a column. So column means it is on. The key means it is index, right? So this is how you club. Okay, look at the statement that we are going to write carefully, right? So it is once again pd dot merge. I'll write my data frame 7, my data frame 6. So left side, that is 7, I want to use the employee names as indices. So left index equal to left side left side data frame, use the indices for merging. So I just have to say true. Okay, I don't have to specify what are my indices, simply say that true. But for the right side, it is a column, so you have to specify the column name. What is that? It is name itself. All right, so let's see the result. Yes, so we get that. Okay, all right. Any doubt with this types of merges? Please go ahead. Okay, next I'm going to talk a set arithmetics, right? During the join, we can do set arithmetic like intersection, union, etc. Many things will come over there. So we will be jumping onto that concept now. So this is called as a joins with the set arithmetic. Okay, so let's try to copy a data frame here. All right, so just see here. We have 3 different names, and corresponding to each of the names, there is another column called switch. Maybe this is a switch that each employee or each candidate likes to have. Okay, jamun, 7 cups, laddu, right? All right, so let me also create another one. Okay, so this is another data frame. All right, just look at this. Another set of names with say drinks, right? What are their favorite drinks? Fine. So now you should understand that out of these 2 data frame 9 and data frame 10, few names are common. So you can make what is called as an intersection. So that's the reason why we created different names over here. So the names are not common. That's the first one. Now, if I simply perform a merge without giving any specification, what happens? Let's see. Okay, so this is the normal merge. pd dot merge. I will merge the same to data frame. This is my data frame. Okay, I'll go with the my data frame 9 and my data frame say 10. See, it actually considers only the common one. This is the intersection. By default, what are the common entries in both the both the data frames, that will be considered. Okay, so I can understand that the result actually consists of intersection of the two sets. You can consider the names as two different sets. So whatever is common over there, you can do that. Okay. But if you want to do this, like I want to specify that explicitly, I want to specify that, okay, I have two different data sets. Show me only the ones which are common in both of them, right? By default, it will do that. But if you want to specify that, how can you do that? You can do something like this. Okay. So I'll just copy this part and then I'll specify what we can do. So see this is common because I want to I want to merge the same thing, but I have to say how. So how is a keyword. So how is equal to, you have to specify inner. Inner join means inner merge or inner join means it is actually you are taking something which is common between the two different data frames which you are considering. So in this case, in our case, what are the two data frames that we are considering? The two data frames we consider are data frame 9 and data frame 10. So out of those two, whatever is common, it will consider that and it will merge. So the same answer like previous. So remember one thing, inner join, inner merge actually, whenever I specify how equal to inner, it actually takes care of the common ones, the intersection. All right. Then we also have other options, like if you want to if you want to club, right? What is called as union. So this is how it's going to work. Okay. It's the same merge, but I will say how equal to, instead of inner, you will say outer. Now see the difference. Some of the entries from the first table have nothing for drink. There is no drink for Ram and Indra, right? But you see what it automatically puts? It puts a not a number over there because it has no idea what I'm supposed to do. Similarly, the entries from the second column, some of the entries from the second column, second data frame have nothing for sweet because only drinks were specified. So you can see for Lakshman and Chandra, you can see that the sweet becomes not a number. This is by default, there is no other option because we have not specified anything, but still we are asking the pandas to club them together. So this is what is going on. All right. Now, during a merge, I have another option that is called as, after the merge, whether you want to keep the left side data, data corresponding to the left data frame or the right data frame. That is also we can specify. So see, this is how you can do that. So this is the same thing, comma, I'll say how equal to, I'll specify this as say left. All right, so left means which data frame? You understand that this is data frame 9. So corresponding to the data frame 9, whatever entries were there, they will be retained, but the result is the merged result. So you see here, so from the above table, that is the previous result, line number 28. So first 3 lines are there because the first 3 lines are coming from the left data frame, that is my data frame 9. Very similarly, I can also write this, but I'll change the left to right. What do you expect? It is a merged data frame, but whatever values were present in the data frame 10, only that will be displayed. Let's see. So from the line number 28, the last 3 will be displayed. Okay, whatever is common will be displayed. Right, so that is Dhaarini, Lakshman, and Chandra, because Dhaarini is common between both of them, and you can see that. That's how the result comes. Okay, so this is called as merge. In the merge, we had various options. You can even specify whether you want to go to left, right, or right. You can also do the outer, inner, etc. Okay, let me know if you have any doubt. Okay, let's see. Let me create another different type of a merge, wherein we can see that column names are same. All right, we have two different data frames where they have same column names, but the entries are different. Okay, so let me show you what I mean. So this is called as a suffix. I can ask the pandas to create a suffix for me. So let me create two data frames. So this is the data frame 11. All right, so let me go for another set. So that should be this one. So it's a straightforward one. So I'm not wasting time typing it out. Okay, so by this time you should be able to catch what is the format in which I am entering, right? So I already have typed it out and it is readily available with me. Simply I keep pasting. Okay, so we save a lot of time. We can go faster, and if possible, we'll finish earlier on. Okay, fine. So this is a data frame 11. This is a data frame 12. So you see, data frame 11 and data frame 12, they have same names under the name column name, but the ranks are different. If you see, right, in the first one, Ganesha gets rank number 1. In the second data frame, that is data frame 12, Ganesha gets a rank 3. Maybe these are the ranks of different events. So I cannot say that based on rank, simply club their name. It's not possible. It's impossible to do that. So in such case, I can club them and I can keep them as it is in my clubbing. Okay, so I can just say that pd dot merge just to specify what are the data frame names. So this one is my data frame 11. Second one is my data frame 12. And now you see on, I still have to use on, simply say name. Name in the sense both have the same names present. So based on names, it will club. But when it clubs, see what happens. It actually puts rank X and a rank Y. It was originally simply ranked in both of them. So it automatically adds the suffixes underscore X, underscore Y for the original common rank. The column rank was present in both of them, but it could observe that yes, the rank values are different corresponding to the specific names over there. So because of that, yes, you can do something like this. Now somebody will definitely ask, no, I don't want to put underscore X underscore Y for me. I want my own suffixes to be added over there. So how do you do that? Okay, so this is the method. I just have to do the same merge here, but after entering this, I am supposed to say what are my suffixes. I think keyword is, yeah, keyword itself is suffixes equal to, enter them inside in the form of a list, and create a list of what you call list of the strings. Okay, so the first one is, maybe I'll write underscore left, and the second one I want to enter should be maybe underscore right. Okay, let's see. Yeah, so that happens. Okay, hope it is clear. Let me know if you have any doubt with this. So the next concept that we are going to discuss is called as aggregation, right? It will also include another concept called grouping, right? We will perform grouping and aggregation, so they will come together. So that let's deal with that. So what I do, I'll create a oh, sorry, I was not typing. Okay. My series is equal to create a series pd dot series. Pd dot just a second, let me check what happened. It's not suggesting anywhere. Okay. My series equal to pd dot series. Yeah, now it's suggesting pt dot series. I'll create np numpy dot the random dot say rand. I'll specify the size as 5. So 5 means 5 numbers are supposed to be created. My series, let's visualize. All right, so 0 to 4 it creates. So totally 5. Now you see the aggregations, in the sense you can actually apply sum, mean, median, minimum, max, etc. can be found in a single step. That's called as the aggregation, data aggregation technique. So initially we are looking at the Pandas Series. So I can simply write my series dot sum. All right, so you can see that this is the result. Adding all of them gave you this. Similarly, the my series dot mean. Again, it generates the mean value of all of them. Like the same thing, you can also apply median, min, max, etc. They are going to work right in the very similar fashion. But now let us go to the data frame and see what's going to happen. All right, so let me create a data frame now. So just see, this is the data frame. So pt dot data frame, column name is A, np random 5 different numbers. Again B, second column, np random 5 different numbers. So 5 random numbers are being generated and put up in columns A and columns B respectively. Right now you see what should happen if I say my data frame, that's the one which we have created so far, dot mean. You can see A has this mean, B has this mean. In the sense, column wise, it actually calculates the mean value. So that's how the aggregation happens. Okay. At the same time, now I don't want column wise, I want row wise. What do you do? What do you do? My data frame dot mean. All right, that's fine. But I have to say, so remember, axis is the keyword to specify whether you want to do anything row wise or column wise, right? So if you want to do that, just do this. So axis equal to, you can say columns, or you can say right, if you want to go with the for every column wise you want to do, that means it is row wise. Every row you are trying to do something. Okay, so the number of rows are kept constant, columns are clubbed together to calculate the average. Okay, then there is another method. This is called as the common aggregation methods are applied to your data frame and you will get a complete result at once. So how do you do that? So this is called as, it's a my data frame, the name of the data frame dot, I have to say describe. Yeah. All right. So simply say describe. You see everything comes into picture. There are 2 columns in your data set. Count equal to 5. In the sense there are 5 entries. Mean of the first column is 0.29. Mean of second column is 0.46. Standard deviation, minimum value, 25% of the value, 50% value, 75% value, and the highest value, etc. You can see that directly. Okay, so this is what is called as the aggregation. But when you get a material for today's session, right, you will see that after this, after the same concept, like my data frame dot describe, there will be a table saying that what are the possible aggregations that you can do and what are the corresponding commands. Okay, so I want you to run that part of the code. Each what do you call, each function present over there, I want you to run and check. Okay, so I am not doing that in class because anyway, it's going to take a lot of time if I keep typing some 20 different aggregation methods, right? So anyway, that's why I'm skipping that. I just have told how do you do that. So just see that and enter it right after this my data frame. So my data frame dot min is a minimum value, dot max is a maximum value, .prod, .sum, etc. Many things are there. Yes, just see that you will understand, right? That particular what you call as a concept. Okay, I'll try to show you one more thing very quickly. So the aggregation, like if you just see like this describe, we may not get a broader picture, a bigger picture. Let me load a actual data and show you what this describe is going to tell. So for example, let me import another data, say library called Seaborn. All right, we are going to discuss Seaborn at a later stage. So right now we are not discussing that, but still why I'm bringing it, because in the Seaborn library, there is a data set which already exists, right? Which is a practical data set. Okay, so planet data set is equal to SNS dot load underscore data set. Just call it planet. So you should know that this exists over there. Then only you can import like this. So a newcomer who has no idea what is there cannot do that. Okay. So since I know it, I'm able to do that. So I'll just try to type the planet dataset dot what shape does what shape is going to do. If you remember, shape should print out the sorry. Oh, my mistake. It's not planet, this planets. Let's check. Yeah. The data set is stored in the name planets inside the seaborn. Now you see the planet data set is actually has been read in the form of so many 1035 rows and 6 different columns. But now you see I can simply ask pandas to describe that. Okay, so this is how you do that. Planet data set dot describe. Okay, if I ask to describe with as a function, it shows more in more detail, right? So you can see that this is how you get the details. The planet data set has a first column called number. What is the count? How many entries are there? 1035 entries are there, right? So for that, what is the orbital period, etc. You can see various parameters over there. Mass is the third column, distance and the year. Now, if you want to see, instead of describe, you know how to look at the first 5 elements. If you remember, what is that? How do you check that? The planet dataset dot head. See, first 5 method that has been used, number, orbital period of that particular entry, mass, distance, and year. In which year you discovered that. But what if you I don't want to see the first 5, I want to see first 10, then this should be number 10 should be entered. So you see, you'll be able to see the 10 numbers. Similarly, what if I want to see the last 5? You can definitely do the planet dataset dot tail. Tail is the last part. So just see the last 5 numbers are being displayed. And if you don't want to see last 5, but you want to see last 20, so make it 20. It shows the last 20 planets of your data frame. Whatever data you have, you can check like this, right? Whenever you read a data, right? Whenever you collect the actual data set from some location, right? You are supposed to do something like this to have a visualization, just to see that, okay, what is there in that? Let me check. Okay, so this is what you do. So mostly in the upcoming assignments, you may have to do something like this, right? Compulsorily, because there may be a question saying that do something like this. All right, fine. Then let's move ahead to the next concept. The next concept is called as split, apply, combine. So this is a very standard procedure in the data frame handling techniques. So whenever we handle the data set, right? We are supposed to do this kind of operation. Why? I'll tell you. I'll show you one diagram so that it becomes very easy for us to understand the requirement. Okay, just see this diagram. Look at this. On the leftmost side, what you see is the input data frame. Let's assume there is a key and there is a, we have data. Now, A is repeated twice with the data being 1 and 4. So when you split, if you do a splitting up of your input, you can split that into 3 different parts. First part containing only A, second part containing only B, and third part containing only C. So how to split that? You can ask something called as a group by. I want to make groups of data containing only A, only B, and only C. Now, once you have a separate, once you have splitted the main data into say 3, 4, or 10 different parts according to the requirement, what you can do, you can apply an aggregation method, sum, mean, right, etc. Anything you want, you can do that. So that's what you see as a third set here, starting from input, split, then apply. You apply a particular function to that so that you can see, in this case, the example is sum. We are taking A, every data, and taking a sum. You can even apply the other aggregation methods. You can go for mean, do whatever you want, right? This is just an example. So you see A becomes 5, B becomes 7, C becomes 9. Then I combine them together. So what happened? My big table got converted into a small table after the combine operation. All right. So this is what is the fundamental idea behind. It's a fundamental idea behind the grouping operations. All right. So normally the grouping concepts are including the 3 steps. You split, you apply some rule, and you combine. So that's the very basic idea behind it. All right. So let's start our examples by considering a data frame. Okay. So this is my data frame, right? You can see that I randomly generated 7 7 numbers, and we also have created a column called key. Right. The most basic type of group by, because our whole concept is group by. I'm trying to make different groups. So if you want to apply the very basic type of group by, it is called as the group by method itself. The function we are going to call itself is called as a group by. So I just have to say which is the column that you want to consider, so that you can club or you can make the groups among them. So how to do that? This is how we do. Okay. So what is the name? My data frame. My data frame dot, you see group by, you just have to mention which column you want. So for example, key. Key is the column which I want to use. Okay, let me show you the result first. All right. So when you see this, it actually, I am not able to visualize anything. Okay, because I have simply apply. I just mentioned that group this according to the key. In a sense, A and A, which you see in the data, they are clubbed, but I did not mention what aggregation I want to do. Correct? Because this whole process has an aggregation, that is the apply method. So apply something. What do you want to apply? I have not mentioned. That's why I'm not able to visualize anything. You see that it's a pandas core group by object. There is a group by already happened. Okay, it's called as a pandas frame group by method. It actually has been applied. It is located at this memory location in my computer. That's also it is saying, but it is not displaying anything. Why you are not seeing anything over there? Why you don't see a table or a data frame like this? It is because you have not applied any aggregation method. Only when the aggregation is applied, it can do that with the group by objects, and it can display that. So just see here, This is what performs the group by dot sum. I'm saying that if you have A, two different values, display only one A with the sum of those elements. So A, B, C, D, you can see, and you are able to visualize that. Okay. All right. So let's look at a different view of this. Okay. Let me bring back the, I think, planets. Do we have yeah, we don't have planet, we have planet data set. All right, let me show you. So this is what it looks like. There are 1035 rows and 6 columns, out of which can I do the grouping for column based on column indexing? So the answer is yes. So this is how you do that. Planet data set dot group by. I'm saying that yeah, based on the method, the first column. All right, let me check that. Can I do that? Method. If I do that, what happens? Oh, same thing, because I didn't mention anything about what aggregation I want to do, right? So maybe because of that. So until and unless you specify what you call as a aggregation method, it will not do that. So inside that, I'll specify one more thing. Let me show you. Let me show you another way, a different concept. So this is what I try to do. I'll specify, right? Show me only the orbital period, right? Make the group by according to this particular parameter. That is a method. Now we have groups of same methods altogether, and I don't want to see everything in the table, right? I want to see only orbital period. Grouping has to be done, and I want to see only that table, that particular column. How do you specify? Just say, or what's this is capital? No, orbital underscore period. Right? Again, this is not going to be displayed. If I simply if I run that again, you see, because no aggregation is being happening so far. I'll copy this. I'll paste it. Now I'm trying to do the what you call as aggregation. Say, no, it's not suggesting. Let me try. Now you see, right? The method, one is astrometry, one is imaging, one is pulsar training, like that. Various methods are, you can see radial velocity, transit, etc. are the methods. So you can see radial velocity, transit, etc. have been clubbed together. After clubbing together, only the orbital period has been considered from the table. Its median has been calculated and it has been displayed. Now you see, so many operations can be done in a single line. One single statement will do a lot of jobs in Python, specifically in Pandas. So when I have a very huge data set and I want to do many operations step by step, you don't have to write a large code. No need of writing 10 lines of code, 100 lines of code for that. Simply understand what you are going to do. Understand what is the Pandas method, Pandas way of writing that code, and write that. Okay, so this is how you can get the answer. Okay. Let me know if you have any doubt on this. All right, the next concept is called as we can try to form what is called as iteration over groups. We can make the groups. We understood that how to make the groups here. And can I do an iteration over there? Yes. So the answer is yes, we can. I'll show you how. So iteration means it has to be a loop. Let me start with the for loop. For a method, comma, group. Method comes from the main table. Actually, the method comes from the data frame or the table, and the group is the one which we are forming by using the group. So this is how you use it. Okay, so group in, that is called as planet dataset dot group by method. Based on the methods, we are trying to make the groups over here. I am iterating over each of the methods and the groups that are formed by. So what I want to do, I will print something. Print. Okay, so I have to use a format specifier. So you can specify the formats in Python strings by using this technique. So 0 means my first appearance, whatever is the variable that comes here, that I have to say that give me 30 spaces. So I'll just write 30s, 30 individual locations for that. Okay, so this actually closes this. The shape, I'll write equal to, then I'll open, I'll write 1 and I'll write close. What is this 0? What is this 1? Yes, I'll tell you. Okay, so let me come out. Yeah, so this is the format I want. Now I have to say format. Format. What is the what is 0? What is 1? I have to tell. What is 0? 0 is my method. Okay, and what is 1? What is 1 in the sense inside the curly braces we have written 1, curly braces we've written 0. 0 means it is a method. 1 means it is group. Dot shape. So we are trying to find out the shapes of the planets that are present over there. That's what is being printed at location wherever you typed curly braces 1. And the method used to identify those group of planets is coming at wherever you type curly braces 0. Now let's run this. So that, oh, sorry. Format, what happened? What's the mistake? Format, oh, okay. Print should be my mistake. Sorry. This is not comma. This is dot format. Yeah. All right. Now you can see astrometry. Wherever your astrometry has been used, the shape is 2,6, right? 2 rows, 6 columns, and so on. So how many eclipse timing variations method has been applied for how many planets? 9 planets, 6 columns in the data in that particular data. Like that, you can see that this is the complete details, right? So you can actually perform the iterations over. All right. Right. If you remember, there is always a method called as right describe. You can definitely apply describe for whatever data frame that you get. You can definitely do the describe for that. Okay, fine. Let's go ahead. Then the next thing is that I want to show you how to apply the filters, transforms, and apply functions. Right. So let's quickly go through that. Right. So that we can go a little bit faster. So let me create a data frame now. So this is a data frame, right? The way how we enter, we form a dictionary, right? So key, ABCD, etc. Then the data one, randomly generated numbers. Integers are developed, integers are used, right? From say 1 to 100. Size is already mentioned according to the required size. So you can see 8. Then the data 2 is random numbers, right? Random real numbers 0 to 1. 8 different numbers, and the columns are specified. So according to that, we have done that. Okay. Now let us see. So data 1 and data 2 are there. I want to visualize the specific aggregations over here. What do you mean by the specific aggregation? Example, I want to see what is the minimum. I want to see what is the maximum. I want to see what is the median, etc. I want to visualize at once. So how to do that? This is a compound aggregation, not a single step aggregation like we did earlier, right? Earlier we simply aggregated, we grouped them together and applied dot median. So median was shown there. But now you see, I want to visualize all the 3 of them. I want to create separate columns for that. So I need to make a group by, and then I need to visualize it in a slightly different fashion. So let's say, what do you call it as my data frame. So this is my data frame. I'll say dot group by. I have to specify which column I want to use when I do the group by. So that is key. All right, key is present in this particular data frame. So I'm using key as the one which as a column name which I want to use for aggregation. Then I'll say dot. Now you see aggregat. There is a method called aggregate. Okay, this method allows with the flexibility, right? You can aggregate at once. This is how you do that. So I will say that. Let me try to write in this way. Let me check whether this works. Can I write min? Yeah, min comma np dot median comma max. Let me check whether this works. Yeah. So you can see this. Data 1 corresponds to the first 3 columns. I specified that I want these aggregations to be displayed. One is minimum value among A. What are the among A refers to? In the line number 61, row 0 and row 6. All right, so that's what is corresponding to this. So what is the minimum value of that? It is 22 itself. So what is the median of that 22? What's the maximum of that 22? But if you have different values, you can see that their values have been corrected. So you see the E value. E minimum is 74, E maximum is 81, 89, 89. So the median value is 81.5. So like that it can be. Similarly for data 2, that is the last column of your data frame. What is the minimum value corresponding to A? What is the median value? What is the maximum value has been shown over here. Like this, you can do the aggregation. This is called by using a function that is a method called as aggregation. Okay, so this is one type. I'll show you another very useful type. Okay, I can definitely say I don't want the min, median, max for all the 2 columns. One of the column I want to find minimum. Other column I want to find the maximum. Can you do that? Right. So the answer is this. The my data frame dot group by, and I have to specify the key. Sorry, key. Then I'll definitely say dot aggregate. But after writing the aggregate, now I have to specify in a different way. Right? You will say that for column 1, do this, column 2, do this. What is the column 1 name? If you see the data frame that has been created earlier, data 1 and data 2 are the column names. So I have to use the same thing. Okay, it's a text, so it's a string. Data 1. Write it in the form of a dictionary. I want to go with min. Okay, I think even if you don't write this, it will detect because min is a keyword in Python. Okay, I can also write the data 2. Want to go with max. Okay, let's see. Yeah. So this min and max, even if you write inside the single quotes, double quotes, still it's going to work. All right. Now, let's try to apply what is called as a filter. Okay, let's try to apply the filter. So for that reason, what I do, I'll try to bring my data frame once again. This is my data frame. Okay, we have the data frame here. What I try to do here is, let me try to write a function, define my filter, and I'll pass a value x to this. Okay, I'll pass x to this. Now, let me try to apply something like Okay, let me try to, this X is expected to be a data frame. Okay, so return X of data 2, because I know that my data frame is going to have a column by the name data 2. Okay, dot, I'll write std, standard deviation, it's greater than 0.1. Okay, so this is my function. This is applicable for any X you pass to this. X should be a data frame. So now let us call this. All right, so that is my data frame. I will apply the group by. So group by what? Group by key. Okay, do this with the key. Then you apply what is called as a filter. After applying the key, right, show me that, right, which actually satisfies this my filter. What is my filter? In whatever you pass as input to this, if at all you see that the data 2 column, its standard deviation is greater than 1, only that will be retained. So like a filtering process. So you are filtering something means whatever passes the filter comes down, correct? So that's what is the point. So these are the various things that actually satisfy the condition. Like this, you can apply that. You can it's not necessary that you have to apply only the one which I have shown. You can write your own function. If you have something in mind, you can write a function to do that, and you can write you can finish that, and this is called as a filtering approach. Then there is another thing that is actually called as the transformation. Recall, there was a special type of functions called lambda functions. We had seen that when we discussed the functions under the Python base. Okay, maybe the first or second class of the whole series. If you refer that, so if you are not able to recall what is a lambda function, I suggest you to go back and check that particular part right now. Okay, so have a quick look. Meanwhile, I'll try to write the code here so that you can understand and you can come back and you can see how it works. All right, so this is what the transform is going to work. You can try to return, or you can try to get a transformed version of the full data, whatever you have. For every filter means whatever satisfies that condition will come at the output. So output size will be lesser than your original size. You see, original data was this, but after filtering, I got only these 4 points. That is filtering, right? But the transformation is simply trying to apply that transformation to each and every element in your data frame. Okay, so this is how you do that. Let me try to do this. My data frame dot group by. I'll specify the column name as based on the keys. You do this, but now don't filter. Apply transform. Transform, you can simply write my squaring function. Every term will be squared, but I don't want to do that. I will show you the lambda function, because when a function is not predefined, right? Whenever you have not written a function over there and you want to apply functions to some of the variables, means you can definitely call the lambda function. So okay, this is what I said. Lambda x, wherever you have x, you should return x minus, okay, x minus x dot. From the x, I want to subtract this. Now you see, for each and every element in your data 1 and data 2, this applies. Okay, so you see, mean of that particular variable has been subtracted, and it is returning the complete data. Like whatever was in 64, every data, its mean has been subtracted. So you get this as the answer. Okay. Then let us go to the next thing. This is called as the apply method. So you saw 3 methods right now. Two methods right now. One is a filter. The second one is transform. Filters out your data frame into a smaller data frame, whereas transform keeps the size as it is but returns different numbers. Now let us check that what is going to happen in the apply. Okay. So this is something like I'm trying to apply an arbitrary function, right, to group my results. I have a group readily available, but that group results I want to change according to some arbitrary function. Okay, so for example, this particular apply method should take a group by object, in the sense the data frame which is already grouped by some column will be passed on to this. Okay, and it will return. You have a facility to return a data frame, return a series, return a scalar, anything is possible. Okay, so let's see how to do that. Let me try to define a particular function first. So that is define normalize. I'm going to call that a normalize function. I'll pass x to that. Oh, sorry. Normalize. So what I want to do, right? I'll simply say that in the x, the data one is equal to, or I'll do that. X of data one is equal to x of data one divided by. So this is the shorthand notation. X equal to x divided by y can be written as x divided by equal to y. X plus equal to 1. You understand that, right? X equal to x plus 1. So the same thing we are doing here. X divided by equal to x data 2. And I want to apply sum to that. So see, very complicated notations can be written in a very simple fashion in Pandas. Multiple multiple operations can be applied in a single stretch and you can get an answer. That's what is the beauty of Pandas. All right, so let me try to do that and return x. Okay, so now I call the function my data frame dot, it has to be grouped by, tell a specific key, column name, in this case it is key. Okay, dot, now you see apply. So what you want to apply? You want to apply this particular function which you have written, that is, this is normalize. Okay, fine. See, the data one comes into picture, which is right after performing your operation. So the data one column should be calculated as whatever was the data one which was there earlier, that is this data one, divided by this is what has been being performed over here. Okay, so that is what you get as an answer. So you see, A, wherever you have A, this data one is same because it's a sum. Sum is same for both, right? Wherever you see A, data one has the same value. Okay. Next, let's go further. Right, now we can actually try to provide our own keys, right? So that the group by can be applied for any given data frame. All right, so this is how you do that. Let me try to create a list first. This is a list and this is my data frame. All right, now you see what I'm trying to do. I'm trying to specify the keys by using my key. So that is my data frame dot group by, and I'll not say that the key of the column, I'll say my key. then I have to say that perform an aggregation such as sum. So you see 0, right? So 0 corresponds to, it's a list with the length matching to that of the data frame. So you can see that this length is actually the length of the data frame. So the first one is 2, then the 2 actually comes here. That is this one. Okay, so this is 2, this is also 2. Then zeros are 3. So before that I have, this is B, this is B. So B can be specified by using 1, 1, and the last one is also considered as B only now. We have only 3 elements because 0, 1, 2 are specified. Wherever you have written 2, right, those positions are indexed as 2 now. So 2 means the first data, then this is 1, this is a 0 data, this is a 0 data, this is a 0 data, this is 1 data, this is 2 data, this is 1. So when I say according to this key, you try to make the group and take the sum. So wherever you see 2, they will be added to this. Okay, so that means 2 means what? This is 22 and this is also 22. 22 plus 22 is 44. Similarly, the other numbers are also added. But when you go for say 1, there are how many ones? There are 3 ones. One is this, that is, sorry, one is this second column, this one, second column, 81. Then you can see the next one comes over here, that is 73. And the next one comes over here, that is 74, right? Look at this. 2, first row, then 1, then 0, 0, 0, then 1, then 2, then 1. So which is 2, which is 1, according to that, you are making the groups and taking the sum. Okay, all right. So this is one method we are applying so far, right? But the same thing you can do by using another approach. This was also supported by what do you call as this is also supported by the pandas. Okay, let me show you something very interesting. Now this is the most common way of doing the group by. Okay, my data frame dot group by. Then you will tell that my data frame of key. Okay, after that say dot sum. This is also possible. So whatever we used to do earlier, either you can stick to that, or if you feel this as a comfortable one, you can definitely use this. All right, then we can also do what is called as we can do the group by using arrays, series, or grouping keys, etc. can also be right also provided for this purpose. One of them we just have seen that is by specifying the list as a key, right? This is one example. Now we'll see how a dictionary or series mapping index can be used for grouping. All right, so for that reason, let me try to write something like this. So let me first create a data frame. My data frame 1 is right. It's a data frame with the index value. So let me try to copy that, and let me try to show what exactly is happening here. So this is my data frame 1. My data frame 1 is this. Anyway, so that means E is ABCD, whatever we have. Okay. Now I'll try to create a mapping now. So it's a dictionary now. Okay. So mapping is a dictionary. All right. Then I'll do this. My data frame 1 dot group by this mapping. Whichever is vowel, whichever is this, according to that we do. So you see, now the keys are changed to consonants and vowels, because I said that, right? If I see A over there, it is a vowel. B, if I see over there, that's a consonant. C is a consonant. D is a consonant. And E is a vowel. So A and E, whichever A and E you see here, they'll be clubbed together to the vowel category. Okay, so that's what you see in this, right? Whenever taking the sum, vowels, whichever dictionary has a value equal to vowel, they are clubbed together. Okay, at the same time, whichever dictionary values are consonants, they are clubbed together, right? That is B, C, and D. So in this table, wherever you see B, C, and D, those will be clubbed together under this. So this is another method of applying the group by. Okay, now I'll show you another different method. You can even apply a function, right, to group by. The group by, which is a function, it actually takes another function as input. For example, the my data frame one, let me consider that. Let me print this out. Now you see, I'll apply the group by taking another function as input. That is my data frame one dot group by. I'll pass it str dot lower. Okay, wherever you see group by a particular column which can be converted into a lowercase, means what? It has to be either a text or a character. Which of them is a text or character? It's a key, right? So group dot lower dot mean. See, whatever you had ABCD capitals are converted into lowers and they have been grouped by, right? So that's a very important concept, right? Which will be very useful. Okay, then we'll move ahead to another very important concept. Okay, so fine. So this is called as a pivot table, right? For the discussion under pandas, this will be the last topic. Okay, so let's quickly look at the pivot table. So for that reason, I'm going to bring in a data set which is present under the seaboard. Okay, it's a different data set. So let me try to bring in over there. Titanic data set. It's a name that I'm going to give, right? This is equal to SNS dot load data set. It's already given inside the seaborn, so directly I can bring it. Titanic. So that actually comes into the Titanic data set. Now I want to see the Titanic. My mistake. What is that? Oh, it's not Titanic. It's a Titanic data set, right? Sorry. Now you see. So this is the data set. It says that whether a person is survived or not. P class, which class that person is traveling. Sex, male, female. Then what is the age, right? Many other data is there. So what is the fare, where they embarked, like that. So what's the class, right? Who, again, it's a who means it's again once again the sex itself, male, female. Adult male, yes or not, right? Deck number, if it is there, it will write. Embarked from where, alive, right? Alone or not, etc. Many details, right? You get from there. So that's what is called as a Titanic data set. Now I'll look at maybe, right? See, this is how the group by works. All right. So let me say the Titanic dot. I'll ask it to make a group by. Is it Titanic or sorry? This is Titanic data set dot group by. I'll say that I want the separation according to whether it's a male or female. So group by sex. All right. Then I just want to see whether a person is survived or not. In the sense, out of how many percentage, what's the percentage of survival rate in male and female in that? What is the average? So I'll just say like there is a common, there is something called as survival. SURVI survived. Okay. Dot mean. Right. So you can see that. So female 74% and male 80%. Okay, so this is a mean value, right? So let's look at another one more step deep inside this, right? So for example, I want to make the group according to the sex, male, female, or the class, right? And I will look at whether they are survived or not, and I'll see the aggregate. I'll apply an aggregate because aggregate is a function which you can apply with the mean. All right, let's see that. So this is what I can do. Once again, the Titanic data set dot, let's go for the group by. Now I will have to specify that I want a group by according to the sex, comma. I also want to discuss about the class. What happens now? The grouping will be done according to the sex and the class. Now I'll apply dot aggregate. What is the aggregate that you want to apply? Mean. Okay, let's see what happens now. Right, this is what I get. Now I want the first, second, third should be coming on the top, correct? Male, female here, first, second, third on the top. What do you do? Recall what was the command over there? Okay, you have to use what is called as unstack. Okay, dot unst. No, it's not suggesting. Let's check. Yeah, unstack. Un. Yeah, unstack. No, unstack S. No, just unstack. Right. So this is what I expected. So the various classes. So the grouping has been done according to the class. Right. Out of the survived, what's the age, what's the P class, etc. Everything comes on the top now. So this is another method. All right. I can do one more thing here. After this, I'll say that I want only survived because it's showing everything, survived, P class, age, etc. Right? I can specify, show me only survived. Now you see, it shows only the survived class. Okay, others will not be shown. This is the much better view of that. Right. But instead of writing this, you see, maybe most of us, including me, right, will feel that, okay, how do I understand, how to remember all these things? This is the order in which I should write. Looks pretty much complicated. Yes, I agree, but this is the best suited method, right? I'll do step by step. I understand what I'm doing here. But if that becomes very difficult to you, we have a method called as pivot table. So what's it pivot table? Very simple. The Titanic dataset dot call the pivot table as a method and tell that what you want, which column you want. That is survive. Then you say, what are your rows? Rows are index. Okay, index equal to, it is male or female, falls under the column with the name sex. Then what are the columns you want to retain? It's the class, right? First, second, third. That class is what I want to retain. So the columns equal to, tell that I want only show me the class. Look at this, look at this. See, very simple. Instead of writing so many things over there, right? Do just this. It's called as a pivot table. Show me the survived numbers, right? From first, second, third class and separated by how many are male, how many are female. That's all. Is it okay? So let me know if you have any doubt with whatever we have been discussing so far. Okay, few more topics are there, right, which are not very important, but those are the parts of the pandas. Okay, so that you will get as a part of the study material that you are going to receive today itself. I expect you to go through that, right? But we may not use it widely, but since it is a part of pandas, that will definitely come along with the complete material that you receive for the pandas. Okay, so highly recommend you to go through that. That's the first job. Completely go through, understand everything we have discussed so far right away from the beginning of the panda session will be there in that document. I want you to type it out, right, and check and understand, because typing the code is also very important. Just remembering will not help you out. Whenever you are doing actual programming, it is expected that you will type it. So that's the first part. And second part, today you will get another assignment. So coming to the past submissions, yes, I went through that. There is a lot of improvement compared to the first assignments which was submitted few days earlier. So I appreciate your efforts. Keep going, right? That's going to help you out a lot. All right. Today there is an assignment that is coming up related to the today's part. That's a group by concept. Very important. That's why a separate assignment has been created for group by.